Hello wonderful person, this is Anton, and in today's video we're going to be talking about a relatively large and relatively surprising discovery that actually occurred in middle of 2016, and it's basically something that we would never expect to discover in our relative neighborhood. We're going to be talking about a galaxy that we actually just found that seems to be really close to us, and the galaxy is known as Crater 2. Anyway, welcome to What the Math. So, astronomers often scan our skies looking for different new phenomena to discover, and one such phenomena happened to be this very large, extremely cold dark matter galaxy known as Crater 2. But what's really interesting about it is that it's actually part of our subgroup of galaxies close to us, and as a matter of fact, it's one of the few galaxies orbiting the Milky Way. But what's even more surprising is that it's actually relatively large and very, very massive. So anyway, let's go to Universe Sandbox. So here's our own Milky Way galaxy. Our sun is somewhere over there. It's kind of sticking out. And this is a galaxy that's pretty well known to us, obviously, but it at the same time still has a lot of mysteries. But what we've discovered is that there's about 57 smaller galaxies that are within about 1.4 million light years away from the Milky Way. And we've discovered quite a lot of them orbiting around our galaxy. There's actually some very well-known ones, like, for example, Large Magellanic Cloud and Small Magellanic Clouds. And these don't actually orbit around our galaxy, they're moving a little bit too fast. And then there are some that actually do orbit, like, for example, Sagittarius Dwarf Elliptical Galaxy, about which I've talked about in one of the previous videos, is in orbit. But then came the discovery of Crater 2. The thing about Crater 2 is that it is massive in comparison to some of these other dwarf galaxies. And the other thing about it is that it's actually pretty close. So let me show you how close we're talking about. Okay, in galactic terms it's close, in human terms it's still kind of far. Now, to represent the Crater 2, because it's full of dark matter, we're actually just going to use a black hole. And specifically, we're going to use Sagittarius A star black hole because the total mass of Crater 2 is about 4.4 millions of suns. And the mass of Sagittarius A star is about 4.3 millions of stars, so it's kind of almost exactly the same. So here we're going to go to a distance of approximately 380,000 light years away from Earth and basically from our own galaxy. And that's approximately somewhere over here-ish. So somewhere over here-ish. I'm going to place Sagittarius A and we're going to rename it to Crater 2. And now we're going to add a few stars to it because it does have stars. It is a galaxy, but there aren't that many. As a matter of fact, what it has around it moves really fast. And the actual black hole in the middle is probably not very large either. But it does have a lot of really unusual properties. Or not, I guess not unusual properties, but the properties that basically define this as a dark matter galaxy. So let's just place some stars here, just so that we can actually give it some galactic-like appearance. And this is going to be our miniature model of Crater 2. So what we have discovered about it, having found it completely by accident, is that being so close to us and being so dark, it's very likely that it's been there forever. We just haven't seen it, and it's been in this region for forever as well. But we're not looking for the right thing, and specifically here we're really looking for the gravitational interactions, which is how we were able to accidentally find this galaxy. And the mass of this galaxy is, or makes it, one of the most massive satellite galaxies to the Milky Way. It's more massive than the Small Magellanic Cloud. Basically, it's somewhere between the Large and Small Magellanic Clouds in total mass. but it's almost invisible. It's very, very dark. It will be impossible to see it with a home telescope. You would need a specialized telescope to see it. But if you were to look at it from Earth, if you were to actually look at this galaxy from Earth, its size would be almost double of the moon. That's how big it is. So it's a pretty large galaxy, but just completely dark because of its content, which is essentially just mostly dark matter. And we've actually found, at least in the last decade or so, quite a lot of these dwarf satellite galaxies, making total 57 now. And some of them include very small, very dark, very chemically enriched, but also mostly dark matter dominated galaxies. And some of these are actually just like this. They're basically a few stars, a lot of dark matter, and a lot of mystery in there. We don't really know exactly what else is going on and how they were formed, but we know that these galaxies were partially responsible for the creation of our own Milky Way, and a lot of their gas kind of get captured by the Milky Way as well. But because this galaxy is so massive, and also because it's so large, as a matter of fact, its radius, well, this is not a good representation of its total radius. Its radius is about 4,000-ish light years. So it's actually somewhere around here in size. This is how big it is. So I'm going to actually just enable orbits for a second, just so you can see how big it is. This red circle represents the actual size of this galaxy in relation to the Milky Way. So it's pretty big. It would definitely be very visible if it was a lot brighter and contained a lot more stars, but instead it's very dark because, of course, it's just dark matter, about which we still don't really know much. We just know that it exists. And so all of these parameters make it fourth largest satellite of the Milky Way, and also one of the most massive. Now, because of all of this, it also is the most extreme low density galaxy that we found in the neighborhood. It basically has very, 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 very few stars. There's barely any stars at all. And the stars that are here probably have complete darkness in their night skies. There's probably not a lot of things in between. If you were to look at the dark skies, basically you would just see the other galaxies. You would see the Milky Way, but you wouldn't really see many stars because there aren't really that many to begin with. And the reason we know that it's basically all dark matter, or mostly dark matter, is because the stars that we've discovered on the outskirts of this galaxy move way, way, way faster than they should. So something is definitely keeping them together. And these stars that are basically orbiting somewhere in here and there and there and there, all of these stars move really fast, and some of the outlier stars move at speeds of like 4 kilometers per second, which is way, way faster than they should be moving based on the total mass of this galaxy. So unfortunately, that's actually all we know about Crater 2. We know its size, we know that it's there, we know that it's mostly dark matter, and we know that it's very large and very massive compared to some of the other similar galaxies nearby. In terms of anything else, we're still going to be studying quite a lot and trying to discover more about this unusual dwarf galaxy, and maybe even discover some unusual new parameters about the dark matter because of this galaxy. And anyway, so that's all I wanted to talk about in this video, and hopefully you learned something from it. And if you did, don't forget to subscribe, share this video with someone who enjoys watching space videos, and come back tomorrow to learn something else. As you can see, now that I've disabled the orbital parameters, this galaxy is barely even visible. It's just a tiny little dot in the middle of other dots. And that's essentially how it really is. And that's why we haven't seen it until 2016. Anyway, I'll see you guys tomorrow. Space out. And as always, bye-bye.